Good morning, good afternoon, good evening, wherever you may be hailing from. This is the CIQ Webinar series, and I'm your host, Eric the IT Guy Hendricks. Today, we're going to be talking about how RLC-Hardened brings active defense to the operating system, LKRG runtime defense, and day one STIG compliance. So, if all those acronyms are confusing to you, you have come to definitely the right place. So this is our bi-weekly webinar series, and I'm really excited to bring in my guests today, although I will say ahead of time that the universe or the tech gods or something did not want us to bring this information to you today because we've had a guest swap, I've had a hardware failure, and we've had technical issues on the background. So if the demo, well, actually, I'll make this admission early on. The demo is pre-recorded. I apologize in advance, but it was either that or just not show you one. So it is pre-recorded, but I have a group of really, really smart people here that I'm really excited to bring in and introduce and get into today's topic. So first off, let me bring in Nathan. Nathan, why don't you introduce yourself?
Hi, I'm Nathan Blackham. I am currently the head of Linux engineering at CIQ. My background is I come from the Linux OS world. I've spent the last 15, 20 years mainly focused around the OS. I was on the team who helped build Amazon Linux at AWS. And also led the team as a manager of engineering on the team that built Amazon Linux 2023. So I've done a lot of operating systems. I've been built it also internal to Amazon and helped kind of build that OS foundation that launched AWS and that AWS is built on top of, and done a lot of things for both client OS and server OS across the years. And I've been at CIQ for about 18 months now, focused on how we can transform Rocky Linux and make it better for all of our clients.
Awesome. Well, glad to have you joining us. And this isn't your first webinar with us, right?
I think it may be for CIQ. I've done a few on it. I can't remember if I've done one before or not. I've done a number of things for CIQ on it. But yeah, I'm happy to be here.
Awesome. Glad to have you with us. And up next is Brady, who I will say was very, very gracious in stepping in very last minute and looking over today's topic in between a customer call. So Brady, thank you so much for jumping in here. And so I'm just going to let you run the whole thing. So just introduce yourself and then cover the topic.
Brady Dibble, Director of Product for Linux at CIQ. I can't speak with the eloquence that Brian Dawson would have, but I can definitely shed some light on components of our Linux product, Rocky Linux from CIQ Hardened, and a lot of the fundamentals that RLC-H builds upon. Definitely some of the hardened packages, FIPS, STIG, and many of those acronyms you mentioned are things that we deal with on a day-to-day basis. So I'm looking forward to the conversation.
Awesome. Well, thank you, Brady, for joining us. And last but not least, our technical resident expert here, Sultan. Would you like to introduce yourself?
Hi, everybody. I'm Sultan Alsawaf. I'm CIQ's Distinguished Linux Kernel Engineer. I've got over a decade of experience working on Linux kernel internals, with my background mainly centered on Android and embedded systems, but I've also got a lot of experience on stuff running on large production systems like servers and stuff. I've been at CIQ for a year now, and I spent a lot of my time working on some security related stuff we're going to talk about later in this webinar, and just improving the kernel in general at CIQ. Thank you.
Awesome. Well, thank you, all three of you, for joining me. This is an important topic, and I want to borrow this from Brian. But when we're looking at security, when we're talking about the Linux operating system, when we talk about security, there's a couple of different camps, and we'll dive into both of these as we dive into today's topic. But there's proactive security and there's reactive security. We're all very, very familiar with reactive security. CVE comes out, it gets a patch, there's a new version of your RPM, you run the update, or maybe you disable a service, remove a library, all that kind of stuff. That's reactive security, and we're all very familiar with that. The problem is, how do you get ahead of these problems? And so Brian, as we were prepping for today's session, Brian shared a very wonderful metaphor of, how do you build Linux? How do you build your Linux implementation in such a way that it's more secure to begin with? And he likes to he likes to liken it to building a house. The most secure way to build a house is to build it without any doors and without any windows. The problem is that becomes unusable because either you can't get into the house when it's done, or you can't ever get out of the house because there's no ingress or egress. So much like a Linux server, that doesn't work because apparently people don't install the operating system just to install Linux. I mean, I do all the time, but apparently people like to have workloads, databases, websites, whatnot.
Crazy. They should run OS for the OS sake.
Right. I mean, that's my opinion, but hey, what do I know? So let me open this up to the floor here. Over the past few years, we've seen an exponential increase in the number of kernel CVEs. Let's not worry about applications. Let's not worry about user space. Let's just look at the kernel for a minute. So what does that increase in velocity mean for security teams trying to maintain patch cycles?
So let's talk a little bit about that just for a second to think about. So what happened is a few years ago, the kernel decided that they wanted to become the CNA, which is the CVE registrar for all of the kernel CVEs. And so what they started doing is analyzing each of the commits that went into it and deciding whether they were security relevant or not, and assigning CVEs associated with them. And so that is where the increase kind of comes from. And so Linux vendors and Linux OS vendors have had to deal with this. And what it means is there's an increase of CVEs that they have to worry about for patching on it. Now, I've been part of a Linux OS vendor for a long period of time. I understand the stress that comes as you kind of deal with all of these security vulnerabilities and make sure that all of the packages that you ship have the vulnerabilities solved. As it comes for the customers on the back end of it, is not only is OS vendors spending more time patching, testing, making sure these products grow out, all the clients and all the customers of all these OS vendors have to keep up with that patching. Now, depending on what industry you're in, depending on what your patch policy is for a given company on it, oftentimes this means you're patching multiple times a week inside of the OS. Whether it's a critical security vulnerability that comes up, whether it just happens that you're rotating through all your hosts and you just have to patch. And so it almost becomes a full-time job for patching and keeping on top of it, and becomes more than one person on it. And just like as the number of servers grows and the number of concerns kind of grow, you just constantly have to be on top of it. And so it causes a lot of stress and money and manpower to keep this up to date, no matter what industry you are, especially as we're growing compute power and we're growing the number of servers and increasing the business. You just are increasing the load that it requires for you to patch those servers.
Not to mention, working on the kernel is typically not easy or not a very common area of expertise for a lot of engineers.
And so before we dive into that, I neglected my duties as host. I jumped right into the introductions, but hello to all of you watching us live. This is actually a live event, so anything we say or do can eventually be used against us. And I say that because there is a chat function in the interface. Feel free to throw your questions or comments in there, and we'll do our best to address those live on the air. So as we get into this topic, if you have some thoughts or if you have something you would like to ask my panel of brilliant people, except we just lost Nate. So welcome to our world today. This has been fun, but we're just going to roll with it. So Brady, do you have any thoughts to add on to kernel CVEs?
Sure. As to your house metaphor, I mean, it's very intentional that enterprise Linux and Linux in general is there with the doors open. It's intended to be DIY. And even a distribution, rather than doing Linux from scratch, which is the ideal way, or Arch, which is of course the preferred way, for an enterprise, even the enterprise optimized builds, distributions, they still have to be flexible, because they don't know what your use case is. So all those doors are open from day one intentionally. It's intentionally not overly opinionated. At that point, you're having to do a lot of work to bring that generic build up to your particular compliance needs. And that's really what it's about, is you have to bring it up to compliance code, because everybody has some compliance threshold or some CISO they're answering to ensure that that Linux deployment is checking off the boxes, crossing the T's, dotting the I's, and then when you go to audit, you're going to pass. But really, mission trumps all with a lot of these things. It has to function. I think we've joked before that the safest Linux server is one that's in a concrete box, not connected to the internet, on the bottom of the ocean. AKA, the most secure distribution is one that's not usable. Usability has to be the function, because if it's not usable, well, then what's the point? That usability can leave some of those doors open. There is no such thing as a secure deployment. There is a more secure deployment. And when mission is the priority, and then compliance has to be met, security can kind of fall behind. For example, with CVE patching, it can be 50, 250 days, quarters before a particular CVE gets patched. That's just the working reality, because even though those patches are coming out very quickly, there are so many steps you have to go through before you can make those updates. Package versions have to be reviewed depending on your process. You've got to go through a lifecycle process and make sure they all work together for your particular stack. If it's the kernel, even if it's a very critical CVE, can you afford to reboot? Well, we think we can get to it next week. Maybe next week, hey, there's some customers using it. We got to do node drain. So there's this constant fight between keeping the mission going, meeting compliance thresholds, which are you're getting constant pressure to make sure all those boxes are checked. And then security comes into play. And it's really a problem, because I think in 2023, there's about 97 unique 0 days that were exploited, like KEV. And there's the average enterprise has like 200 plus open source packages in their given deployment, and that's like 50 CVEs a day. So you're getting bombarded by all these CVEs. With the advent of AI, as much fun as it is, it's not just for enterprise and business and ChatGPT. It's also about how quickly can threat actors spin up dozens, hundreds, thousands of new attempts to find new exploits. And so just as fast as AI and other tools are improving our ability to patch things, they're finding exploits faster. So reactive patching just isn't enough especially when it's coming third against compliance and mission.
Well, and it's tough, Brady, as you start talking about it, talk about how the mission trumps, right? It means that people sometimes are delayed in patching to be able to do it. And we have seen some massive breaches and massive security issues that have happened over the last couple of years, where big corporations have been down for days, or information has been leaked on it to various different actors. And so there's a real cost to having your exploit being exploited, right? And having a hacker kind of get into your system. It is a very tough balance between, do I patch now? Do I reboot now? Do I take the downtime? And it's tough. And I feel for customers across the board. I'm glad I'm on the OS side, where I'm just producing and delivering the patches, and I don't have to make that trade-off, because it's difficult these days to go like, when do I patch? How often do I patch? And how do I balance that risk between staying up and solving the mission and being more secure?
So how can we better position the operating system so that out of the box it meets certain criteria? It's one thing to be up on patches, but that's not what a lot of systems administrators are facing. More and more, we're seeing industries go to some sort of regulation, whether that's PCI DSS, or whether that's HIPAA, or FIPS, we're seeing more and more organizations requiring that as just kind of a standard. So is there a way to become compliant, so to speak, on day one?
It's a great question, Eric, and it drives a lot of the thinking that I've had over the last year and a half or so. We've been thinking through it, like STIG, CIS. These are all really great standards. Now there are things inside of them that don't always make sense from a security standpoint, but they give you a good basis to provide a secure operating system. But it's all very reactive. You're building, especially when it starts talking about CVE and vulnerabilities, you're building your system in a way that you're providing config to provide the least amount of attack surface. But the attack surface that you have is really tough to kind of protect, because STIG and CIS, just as Brady was talking about, mission trumps, right? You have to make sure that it's operational, which means you still present an attack surface. And so STIG is great. I love STIG. I love CIS. I love the standards of trying to make sure that you have a minimal attack surface, that you have the right configuration to make your operating system as secure as possible. But in the world today, it's not quite enough. And so you talked early on about the difference between proactive and reactive security. And as you do that, you've got to think about the operating system a little differently. And so this is what we did in terms of what goes into the thinking of RLC-H. We thought about what are some of those things that we can proactively prevent vulnerabilities from happening. And we've seen this across the industry. The industry has been moving this way in certain things on it. One of the things that have been standard for about 10 or 15 years is inside of GCC, most operating system vendors will build with stack protection on. And this provides protection when a stack gets overrun and other stuff that prevents you being able to run code, and it provides crashes on it. And so as we're thinking through this, and our talented Solar designer who works with us and has built a lot of the tools, or worked with a lot of the tools in Rocky Linux Hardened, has provided a way so that we're focused a little bit more on proactive security. How do we shut down certain classes of vulnerabilities before they can interact in your system? Or if we can't shut them down, how do we limit the blast radius and limit the exposure for it? And that's really what we're trying to pitch as we start talking about RLC-H and Rocky Linux Hardened. Do you want me to go into details of what's all included, or Brady, do you want to give some of the details there?
Yeah, let's see. Yeah, we at CIQ have seen this pattern repeated over and over with the similar customers, similar situations, very different customers, very similar situations. It all comes down to the same patterns of, here are the windows I need to lock, the doors I need to close, the boards I need to put up to protect my environment. And that's why RLC-H is intentionally opinionated. It's making trade-offs for not just compliance, but keeping you functional while adding security. And that security is not just the hardening. When people say hardening, oh, this is hardened. Well, okay, I have hardened the configurations so that now I am STIG compliant and I run OpenSCAP and I have my percentage and great, I'm safe, right? Well, to Nathan's point, it goes much deeper than that, because the guidelines, the security profiles are not designed to bring everything to the level of security that threat actors are actually targeting. It can't keep pace. And it also can't lock down everything, because it can't consider every possible scenario and implementation that a customer might have. So there are still doors and windows that are open that are not closed by STIG, that are not closed by PCI DSS. And that's where we move to proactive hardening, actual code level changes that shut those windows, shut those doors. There are configurations, for example, I think about 60, 70% of high severity vulnerabilities come from memory corruption. That's why some of the things we're doing are hardening glibc, providing hardened malloc, and this is attacking entire CWEs, common weakness and enumerations. And to Nathan's point, if not outright eliminating those CWEs, it is at minimum mitigating them significantly to buy customers time. There are about 7 packages that are added or modified in RLC-Hardened. As mentioned, we have a hardened build of glibc. There's hardened OpenSSH, turns off a number of services which are not commonly used. There is changes to password encryption and password security, YesCrypt and password QC. In addition to that, we've eliminated some. Well, there is tuning of all of this, of course, so a tool called Control, which gives you the ability to ensure that your settings don't get lost upon reboot and to tune some of the levels of security, because there are trade-offs as well. How secure do you want to be? The more secure you are, again, there's a trade-off. There are potential impacts to performance, and you're turning off things that you didn't have not known that you were using or some of your users were using. So there is dialing back and forth to get it right. But Control allows you to keep those settings and deploy those settings across multiple nodes. The LKRG, however, that's the real star of the show. I think Sultan probably is best suited to talk about how cool LKRG is.
Yeah, I don't know, Eric, if we want to jump into that just yet. I can talk if you'd like.
I think Brady set you up really well to introduce what LKRG is. So let's dive into that.
Okay. LKRG is a Linux kernel module that does proactive security. So instead of doing something that makes the operating system hardened in advance, like when a program is compiled, it's actually checking stuff in the operating system at runtime inside the Linux kernel to protect the Linux kernel from exploitation. And there is nothing else of its kind that does this proactively. So it will run in the Linux kernel and check what's going on in the Linux kernel to see if there are signs of an exploit taking place. And when it detects that, it will shut it down immediately.
And I think something that might help people understand what LKRG is to also define what it is not. We're not talking about antivirus, and we're not talking about a rootkit detector here in a pure form, but we're talking much deeper down the technology stack. Is that right?
Oh yeah, this goes a lot deeper, and pretty much the way that it works is that it looks for the pot of gold at the end of the rainbow that all exploits try to get to in their long, complicated chain of operations. What do you want to get at the end of the day? For example, with a local privilege escalation, you want to get root access. That's what LKRG looks for. It doesn't look for the complicated chain of what are you doing? It looks for, did someone get to that pot of gold at the end of the rainbow? So it doesn't matter how someone tried to exploit the system. It looks for what the goal is when those exploits take place. And it detects those irregularities and uses that to shut down exploits, regardless of how the exploit takes place.
Yeah, I mean,
But go ahead, Nate. Sorry.
One of the things to think about it, and I am not as deep down the stack as Sultan. He still runs circles around me from a technical set. But the way I think about it is like LKRG takes a snapshot of the picture that should exist inside of the kernel and then detects when it's changed. And when there's valid changes, it updates its picture. When there's invalid changes, it flags it. And it will either report on there's a bad actor, it will crash the given process, or just block it from accessing whatever it needs to do. So that picture that is supposed to be the pot of gold at the end, the right set on it is always correct. And it knows when it's correct and knows when somebody's trying to tickle it and change it and throw in the false gold rather than, the real aspect of it. At least that's how I understand LKRG. Sultan, correct me if I'm wrong, but that's my...
That's exactly what it does. It looks for what's supposed to happen normally and correctly. And if it sees something that happened without the correct steps happening before that, it'll say, oh, no, that's not right. It's like it finds someone in your house who didn't enter through the front door. And the only thing that is normal is for someone to enter through the front door. If there's someone in your house and you know they didn't enter through the front door, they're not supposed to be there. That's what LKRG does.
And we come equipped today, don't we? We've got a live, well, not a live demo. We have a pre-recorded demo that we put together. So let me pull that up real quick. Sultan, you ready to kind of talk through that?
Sure.
Awesome. All right. Well, here goes our LKRG demo.
So this references the attack vector used by a specific CVE, but it's used by a ton of local privilege escalation CVEs related to the kernel. It's talking about the pot of gold at the end of the rainbow, the commit creds, where the exploit goes for that function inside of the kernel to change the credentials of a process or thread without going through the front door of the house. And before, without LKRG, you can see that it gains root access just fine. UID 0, root, it got it, it's in. There was nothing that stopped it from taking place. And then now with LKRG loaded, the exploit is going to be attempted again, and we will see what happens. And oh, it got killed. What did LKRG say? LKRG spotted that something took place that was not supposed to happen. The credentials for that task were changed without going through the proper channels to do it. It saw someone claiming to have root without having gone through the front door as expected to get root. And what LKRG does that is most powerful is that it doesn't stop a task or a thread or a process from changing its credentials on the fly. It stops it when it attempts to use those credentials. It stops it from trying to use the fake driver's license at the store when they try to buy something instead of the moment they create the fake driver's license. And when it sees that they're trying to use that, it kills the process immediately, and the program no longer executes any more code in user space. It is killed without having any more chance to even react to LKRG taking an action.
Now, some of the cool features about LKRG, and I'm going to put Sultan and give him some credit here in a second, is that like LKRG a couple months ago went 1.0. And one of the big aspects of that is operationalizing it and making it ready for production environments, which is wonderful. And we celebrate that. It's in Rocky Linux Hardened. But I want to talk about what's going on right now in LKRG a little bit. There is some press, you can go out and find it, that basically said they can get around LKRG. And Sultan and Solar and others have been working on how do we improve LKRG, not to just block this workaround that they're doing, but how do we detect when people are doing similar things on it? And they're building additional features into LKRG that will show up in Rocky Linux Hardened soon on it, and it will provide just a better net around the kernel, around that pot of gold, to detect when there's problems and people are doing it and detecting certain things and making it happen. And so it's awesome as, you know, a director here, as the head of Linux engineering, to see like some of the technical improvements that are going, and that it's not just one and done. Like, we're continuing to try and expand the scope of where proactive security happens inside of Rocky Linux Hardened. So stay tuned as we kind of continue to make more and more changes to LKRG and have it protect much more of your system and different aspects of vulnerabilities.
So one of the questions that always comes up in security conversations, and I've seen it already in the chat, is, okay, so this is running on my system. What kind of performance impact can I expect?
That's a great question, Eric. And I'm sure many people are scarred by the days of antivirus on Windows and their computer slowing down to a crawl when it tries to do something. LKRG is not like that, luckily. The performance impact is about 2.5% overall, and that is not even factoring in additional performance improvements that we at CIQ have made and contributed to LKRG as an open source project. So even before those improvements, the overall performance impact is just 2.5%.
And part of it, let's put this in practice, right? If you look at the standard usage of cross systems, right, you're using about 50 or 60% on a really busy system. So is it going to cause additional time to complete certain actions? Yes, but it will be minimal. I mean, depending on how often your tasks are run, will it use a little bit more CPU? Yes. Will it use a little bit more memory? Yes. But usually you have those buffered in your system anyways. And it's not like it's 10% where you're seeing a noticeable slowdown. Most people won't notice that impact. There will be some, and every workload's a little different. And so depending on your workload, you'll see an average different. One of the things, I've been in the industry a long time, especially on operating systems, and everybody's all like, oh, benchmark it for me. What's the benchmark? What am I going to see on performance? And it all depends on your workload. Now, the 2.5% that we have measured is based off of a synthetic workload, based off of something that we actually could measure the performance with on it. And we think that's about where the maximum percent is that you're going to kind of see. It might be less, it might be a little bit more, but it's probably not going to be as noticeable depending on what workloads you're running and where you're running it.
So a follow-up to my earlier question, Mark in the chat actually brings up a really good point. With LKRG, is there a danger of false positives, i.e. blocking legitimate usage?
LKRG strives very hard to not generate false positives. At present, I am unaware of any false positives that take place within LKRG. And the only false positive that I have seen in my months of working on it was actually not even an issue, because it would show up when a process was dying anyway. You would see a message from LKRG saying, oh no, this is someone trying to do something nasty, but it was a process that was already on its way out the door. LKRG did not do anything differently that impacted how the system operated. So are there false positives? If there are, I don't know of any, and I don't believe Solar knows of any either. So it's very much something that is a big goal of LKRG, is to not generate false positives.
And so along that, there used to be false positives in LKRG. So you can go out and look through forums and other sort of stuff, and you'll see some. And Solar, Sultan, and Adam, who is one of the other developers on it that's not at CIQ, on LKRG, have worked hard to try and reduce those false positives, and we'll continue to do so. So if you find some, report it, and we can go fix it.
CIQ is very much committed to the success of LKRG and all of the open source work that goes into it. It's the first and only company that has basically sponsored development on LKRG that I know of. And we're the only ones shipping it in a product, so we stand by it.
Which is great. And going back to the compliance question that you asked earlier, one of the big things in compliance today is secure boot and making sure that you're able to do secure boot, which makes it really hard when you deal with these third-party KMods for it, because secure boot requires that a KMod be signed. And this is one of the critical things about Rocky Linux Hardened, is it's the only operating system where LKRG is signed by the operating system's secure boot key. So it auto gets load. You can load it in secure boot. You can run it in secure boot mode with LKRG, and it will work just fine.
Awesome. So one thing I'm really excited about with RLC-H, and that's Rocky Linux from CIQ Hardened, for those playing acronym bingo at home, is that LKRG is just one part of that. It's just one aspect of RLC-H. So I want to zoom out a little bit and kind of look at what are some of the other features that come included with RLC-H, like LKRG.
So Brady mentioned a bunch of these before on it, but let me walk through just a little bit and give you a little bit more details on it. So hardened malloc is one of the other big preventative measures. And what hardened malloc is it creates buffers around memory allocations, and it creates detection pages, so that when something gets written outside of the boundary of the buffer, it gets detected and handled on the kernel, and usually causes a crash of a program. So buffer buffer overruns no longer cause code execution or potential code execution or finding, sensitive information in the memory, but just get stopped early on in the process. We add additional password security to it. So YesCrypt is an encryption algorithm that is changes the SHA-512 on it. So it adds memory time complexity as well as CPU compute complexity on it, which helps protect against ASICs coming and trying to crack passwords on it. It uses password QC that determines the strength of the password and make sure that you have not just a password that is cryptographically sound, but also takes in factors like entropy and other things into the complexity of the password to make sure that systems or that people use complex passwords that are harder to guess and harder to compute when it comes to using things like John the Ripper or other things where you're trying to crack a password. In addition to some of those on it, we do some surface reduction on it. So OpenSSH, as Brady mentioned, reduces the number of libraries linked to it. One of the cool features of it is because of how OpenSSH is written on it, is that there was a exploit for XZ a year or two ago on it that affected a lot of OpenSSH clients because OpenSSH links against a program that links against XZ. So it gets loaded as part of the OpenSSH program and libraries associated with it. With the OpenSSH version in Rocky Linux hardened, it only loads XZ and the requirement for it for a short period of time during startup and then removes it from the linking. So it's no longer in memory. And so the exploit doesn't have an opportunity to use it to exploit into OpenSSH. We do the same sort of thing with some of glibc hardening, where we break down and try and stop your environment variables from crossing security boundaries. It's not perfect, but it does reduce a lot of the scheduling on it. Now, those are some of the active and proactive features. The other aspect that comes with RLC-H is the ability to do some of those hardening foundations that we talked about earlier. We have STIG versions, we have CIS versions, and we have scripts to be able to take and validate that you are STIG compliant and CIS compliant up to the point that an OS can do. There's a number of things inside of CIS and STIG that you have to do about the client machine on it. So you can't get 100% compliance out of the OS, but we get as close as we can with as much as we can to be able to make that happen. So whether you find yourself in a government environment, in a adjacent environment, dealing with financial services, whatever the case may be, you can come out with some of these established standards and say, at install, I am 95% of the way there. And I can show it through OSCAP, the OSCAP reports, to be able to prove that it's there and everything like that.
And 95%, that's not just a wild number. That's the actual number that the gold image is out of the box.
Yes.
That's really cool. 95% of the way there on day zero, really. That's really cool to hear. So we've had a few questions come up in the audience, and I've been doing my best to kind of weave them into the conversation. But I want to address a few of these specifically. So I'll open these up to the whole group. Question we had, is there an SBOM, software bill of materials, for RLC-H packages?
Go ahead, Brady.
Yes, every image that is built has an SBOM created.
Awesome. And then, so one of the questions that might merit some conversation is, are the changes we're making at the kernel level in the kernel code itself, or is this something that we're adding onto it? The heart of the question was, is this being released by kernel.org?
Sultan,
No.
you want to talk about the kernel?
Yeah, it's not part of something from kernel.org. It is an external module that is loaded into the kernel and it is its own project, unaffiliated with kernel.org.
And I think it's important to point out that while LKRG is not part of the kernel itself, LKRG is open source.
It is open source, and you can take LKRG and you go build it for any of the kernels, and the open source team checks compatibility of new kernels from kernel.org. Rocky Linux Hardened is based off of Enterprise Linux, and so it uses the Enterprise Linux kernel. And so when you get Rocky Linux Hardened, you get a kernel that has been through all of the Enterprise Linux process for it. And it's the same kernel that you would use if you were to take Rocky Linux 9, for example, and install it yourself. You get that same kernel with the LKRG added into it as an external kmod to be able to do it. So all the applications where you rely on certain levels of the kernel and you know that they work with Rocky Linux 9 should work with Rocky Linux Hardened. Now, I'll always do the caveat of you always want to test all of your applications on it, because while I use the word should, there are some applications that may, cause some issues, as we talked about before. We're not aware of any that would cause issues, but you always want to test before you put something into production.
Test before production. That would have saved the sanity of a great number of systems administrators over the years. So turning our attention a little bit to FIPS, question from the audience was, is Rocky Linux 9 FIPS compliant?
Great question. So Rocky Linux, the community edition itself, is not. Every month, every day, NIST, the organization behind FIPS compliance, raises the bar, essentially. So Rocky Linux, as it stands today, being a rebuild of RHEL, some could argue that there is some inheritance of whatever RHEL's FIPS compliance is, but the code delta ages quickly, and every time you go to a new minor version, the delta becomes effectively too wide to even be considered compliant if you look at it from the side or at an angle. And generally, when you're looking at a FIPS compliant or certified module, you need to stay on that module, but you also need to get CVE patches. So for Rocky Linux from CIQ, we pursued FIPS certification completely independent of RHEL and for Rocky Linux. So we have pursued FIPS compliance certification for Rocky Linux from CIQ 8, which covers both 8 and 8.6 versions. We also are pursued 9.2 and 9.6, and we will continue to pursue FIPS certification for every 0.2, 0.6, and 0.10 version. This covers the 5 main packages, that is kernel, OpenSSL, libgcrypt, GNU-TLS, and NSS, which are used in Enterprise Linux for the vast majority of your encryption. We have our CMVP, meaning the packages are actually certified for FIPS 140-3 for, off the top of my head, I think libgcrypt and our 8 and 9.2 kernels. And the rest are coming in the very near future for complete coverage of RLC-H, 8.6, and 9.2. We've also got our 9.6 packages in the MIP list, which means they've been approved by the lab, and it's just waiting for NIST and the government to look at the paperwork and give it the stamp. So we had to do more, however. When we went through the certification, the bar had been raised because the labs learned more about what the requirements are. So there are multiple code level changes that CIQ had to make to bring these packages up to the bar for FIPS compliance. And that, as a result, we don't have any caveats associated with our packages that maybe were there during previous packages that went through this process. And then, as a result, all of our stuff, I'm mentioning that we're a very open source first company. All of these changes are available through our GitHub, and we encourage you to go take a look if you have any questions. But the actual packages, the versions that were certified by the lab, approved by the lab and have been certified by NIST are all available through RLC-H.
Beautifully put. I love it. And then we're kind of coming to the end of our time together. So I've got one last question from the audience that I wanted to bring to the surface. And that is, how does RLC-H impact traditional HPC or high performance computing systems?
Well, I mean, it depends on what your implementation is. RLC-H out of the box is going to be somewhat agnostic to RLC, HPC systems. You bring your open HPC, but otherwise, there are certain nuances that you need to take into account for like a werewolf deployment, where a werewolf has some conflicts with STIG and certain configurations. So, for example, the gold image for RLC-H that's based on STIG is not a werewolf gold image. We do have other webinars we can go through from our webinar, the Werewolf Pro product, which takes these things into account. But for HPC deployments, for ephemeral loads, deployments, you're going to have to make some additional tweaks on that gold image. But you're already so close to where you need to get to that it does gets a lot of the work done up front for you.
This is why I love Brady on the call. See, I'm not an HPC guy at all, and I'm learning it the more I stay at CIQ. But having Brady, who just understands that world a lot better than I do, is wonderful.
I could spell HPC at this point, so I'm getting better. Well, I really want to thank you both, or both. I get my numerical right. I want to thank all three of you for joining me today. Brady, especially, for jumping in last minute, and Sultan, this was your first webinar, and I think you did a fantastic job. Really glad that you joined us, and this means that I'm going to drag you on this more often.
Oh no.
That's the problem. You show up, you do a good job, and then you get volunteered in the future. So, that pretty well covers the questions and our topic for today. But that is not all. We are producing more and more content out on our YouTube channel. This webinar and others like it will be available within a few hours, if not a day or so, of the live airing. So you can head over to the Control IQ or CIQ YouTube channel and catch the replay of this webinar. We're also starting to produce tech tips, thought leadership videos, a little bit of everything over on our YouTube channel. So if you haven't dropped by there recently, make sure to drop a like for this content and subscribe. Also leave a comment in the comment section if there's any topic that you'd like to hear. Brady, and is there anywhere you want to send folks, LinkedIn or blog or anything?
Please check out our LinkedIn profile, but also CIQ.com has a whole list of blogs, webinars, white papers, references. There's some very interesting blogs in particular about RLC-H. Check out the systemd core dump, which shows how LKRG prevented some exploits that were in Enterprise Linux unpatched for a number of months, and how it got at that proactive hardening, outright prevented it and mitigated it for months before it was actually patched.
Awesome. And then, we did have one last minute question come in. If you want to learn more about LKRG, you can go to lkrg.org. Nate, is there any closing thought or anywhere you'd like to send folks to learn more?
No, I think you guys have covered a lot of it. One of the things is we really try and take a lot of open source. Go look at the CIQ GitHub page on it. We are putting more and more out there. One of the things as the director of Linux engineering is I'm always trying to look at ways of how do we get better and release more into the open source world. And more is coming. I'm excited for some of the things that's on it that we weren't able to talk about that's on the roadmap for us to come. So stay tuned.
Well, Nate just volunteered to be on a future webinar as well. So Sultan, any closing thoughts or anything, anywhere you'd like to send folks?
If you'd like to look at like what's been done on LKRG, you can go to GitHub and see the commit history just to see like how much stuff I did, which was sponsored by CIQ. So you can see that CIQ has put a lot of work into LKRG. It's not like we just made one or two changes and said, oh yeah, we're shipping LKRG to the world. No, it was a lot of extensive work on it that we've invested and continue to invest on it.
Just the most recent release actually added like 1,400 lines of code, but removed like 2,700. I may have those numbers transposed, but there's more than 2,000 lines of code removed from LKRG before it went to version 1.0. So definitely check that out. There'll be links in the show notes below. But until next time, I didn't do my due diligence. We're talking about RLC. We're talking about RLC again in 2 weeks. I forget what the topic was offhand, but we are talking about RLC. I'm doing great as a host today. So with that, I'm going to just end the call. We're done. but on behalf of my guests today, Brady, Sultan, and Nathan, thank you all for joining us, and we look forward to seeing you again in a future webinar. Thank you so much, and we'll see you next time.